Hi guys, I'm going to go through the homework questions that were submitted. It's 31B, 38, 39, 41, and 75. So let's start with 31. You can fast forward to where you need to get. A survey of drivers began by randomly sampling all listed residential telephone numbers in the United States. Of 45,956 calls to these numbers, 5,029 were completed. The goal of the survey was to estimate how far people drive on an average day. What was the rate of non-response? So just a quick friendly reminder, non-response means the people who did not complete the survey. What I did to figure this out is I just said, okay, well, what's 5,029 divided by 45,956? And that is equal to approximately 10%. So that's the response rate. So that would make the non-response rate approximately 90%. And just because I'm typing, I don't have that little approximation symbol, so that's why it says equal. If you have any questions, write it down and let me know. Part B says, explain how non-response can lead to bias in this survey. Be sure to give the direction of the bias. I want to be very clear that on the test, it may not say to give the direction of the bias, but on all bias questions, I have stated that I expect you to say three things. What kind of bias was it? And you don't necessarily have to say non-response. You just have to describe that some people are not responding, or it's a voluntary response also. It looks like, never mind, it's not a voluntary response. However, you just have to describe the situation, how it's not random. That's the first thing. The second thing you have to always do is describe the direction of the bias. That means the results that the survey produced are either higher than what the population would think or lower than what the population would think. And finally, for the third thing, you have to say why. So we know it's non-response already. That's the first part, the what kind of response or what kind of bias is it? The second thing would be the direction of the bias. Okay, so 5,029. Now it doesn't say we can't tell the direction of the bias here, right? It says a survey of a driver began by randomly sampling all listed residential telephone numbers of the United States. Of 45,956 calls, 5,029 were completed. It doesn't say how far they went, but so we would just say, now again, we would have to say the direction of the bias is going to be higher or lower than the population truth. We don't know the results. Why will it be that way? Well, the 90% of people who didn't respond could be very different than the 10% that did respond. So there's number 31 for you. Number 38, archaeologists plan to examine the sample of 2-meter square plots near an ancient Greek city for artifacts visible in the ground. They chose separate random samples of plots from floodplain, coast, hills, foothills, and high hills. What kind of sample is this? A cluster sample is that advisory, okay? So that would be where I have the different advisors in a hat. I pull out 5 advisory teachers. Everyone gets sampled. A convenient sample is where I stand at the front at a basketball game and ask everyone their questions. A simple random sample is where I have 1 hat and I pull out 100 people. A voluntary response sample is where I post something on the internet and people choose to vote. A stratified random sample is what this is. There is more than 2 hats here. So a stratified sample is for observational studies where we just examine things, and we have 2 or more hats. So our hats here are we're taking random samples from floodplains, coasts, foothills, and high hills. There's 4 different hats there, and that's why it's D, a stratified random sample. On to 39. Your statistics class has 30 students. You want to call an SRS of 5 students from your class to ask where they use computer for online exercises. You label the students 0, 1 to 30, and you enter the table of random digits at this line. Okay, so it wants to know what does your SRS contain. So 14, is that between 0, 1, and 30? Yes, it is. So we'd say 14 is part of the sample. We would cross off 45 because that's not between 0, 1, and 30. 92 we would cross off. 60 we would cross off. 56 we would cross off. 31 we'd cross off. 42 we'd cross off. 48 we'd cross off. And 3 we would not cross off. So now all of a sudden we have 14 and 3, so we're going to cross off this one and this one, okay? So next we have 71, not part of it. 65, not part of it. 10 is part of it, okay? They all have 10 for their third number, so we can't cross anything off yet. We have 36. We have 22. All right, so we have 22 is all their fourth number. We need to keep going. 53, 22 again. The person who's very quick is going to say the answer is C, forgetting that these are students and you cannot have repeats, so you cross it off, which means we're going to cross off C. 49 is not okay, but 6 is okay. And that would be D. All right, make sure that you know how to describe that in words too, labeling all the students in alpha order, 0, 1 to 30. Enter at the line given, go by 2 digits. If it's between 0, 1, and 30, it's part of your sample. If it's 0, 0, or 31 to 99, you throw it out. You cannot have repeats, and you stop after you get a simple random sample of 5. I said that very quick, so you may want to listen again if you're struggling at all. 41, an example of a non-sampling error that can reduce the accuracy of a sample survey is using voluntary response sample to choose the sample. Well, that's a sampling error. That's how we take it, okay? So this is saying an example of a non-sampling error that will reduce the accuracy of a sample survey. A voluntary response sample is a sampling error. That's how it's the statistician's error, okay? They decided to have a voluntary response sample. Using the telephone directory as the sampling frame. Again, that's the statistician's error, so that's a sampling error. Interviewing people at the shopping malls to obtain a sample, that's a convenience sample. Again, that is the statistician who did the error, so that's a sampling error. Variation due to chance in choosing a sample at random. Okay, we don't know. Inability to contact many members of the sample. That is also the statistician's error. So by process of elimination, we have D. Variation due to chance in choosing a sample at random, that is a non-sampling error. So if I asked everyone how many hours of sleep they get, and I start marking it on a dot plot, you know, if I could get some outliers, right? Most people could be around here when I'm checking them off, but just by chance, I can get some variation. And that's going to give me some accuracy of reduce the accuracy of my results. All right, moving on, you guys. Number 75, is yawning contagious? According to the popular TV show Mythbusters, the answer is yes. In March 9th, 2005 episode, the Mythbusters team presented the results of an experiment involving 50 subjects. All the subjects were placed in a booth for an extended period of time and monitored by a hidden camera. 2/3 of the subjects were given yawn seed by one of the experimenters. That is, the experimenter yawned in the subject's presence prior to leaving the room. The remaining subjects were given no yawn seed. What were the results? Of the 16 subjects who had no yawn seed, 4 yawned. Of the 34 subjects given yawn seed, 10 yawned. Adam Savage and Jamie Heineman, the co-hosts of Mythbusters, used these results to conclude that yawning is contagious. Explain how you could use slips of paper to randomly reassign the subjects to the treatment groups, assuming the treatment received didn't affect the response. Okay, so we have 50 people. What we would do is we would say, we could put everyone's name in a hat. We could do it a couple different ways, okay? If we want to use people's names in a hat, we would say 50 subjects, 50 subjects, write their names on similar size, or on equal size paper. They put the paper in the hat. The statistician or researcher shakes the hat up. The first 50 names get the yawn seed, and the 25 don't. The 25 remaining do not. Okay, suppose we use your method in A to redo the random assignment of 50 times. The Fathom dot display the number of subjects in the yawn seed group who yawned in each of these random assignments. What conclusion could you draw? So they did this whole thing 50 times and they plotted what happened, the number of people who yawned. What conclusion could you draw about whether yawning is contagious? All you have to do here is describe the graph. We haven't talked too much about the graph right now. It's not your review, so I won't worry. Just draw a conclusion about, hey, how many people yawned in the group that yawned, or that got the yawn seed. Okay, just draw some kind of conclusion. I don't really care too much about this. I care a lot about A right now. We're going to spend a lot of time looking at graphs and drawing conclusions, so that's not a big deal to me right now. If you have any other questions, let me know. I went fast through this, so you may have to stop, pause, rewind, and let me know if you have questions. Have a great night, guys.